we're going to focus our attention now on the tangent problem. And we don't know what a tangent line is. Okay? I'm going to give you a rough intuition of a tangent line. In fact, here it is. Here's the rough intuition of a tangent line, right? This red line is the tangent line of this blue curve at this particular point. At some point here, that is the tangent line to the curve on that point. Okay, so I've got a picture that shows me what a tangent line is, but what exactly is a tangent line? Well, I won't actually be able to define that until chapter 3. But for right now, we're just going to develop an intuition. So we all sort of have a general understanding of what a tangent line is, and then we'll be more careful of defining it mathematically. So to help us develop that intuition, I want to return to some geometrical concepts. This one is sort of easy to look at. For a circle, if I were to label a point P on a circle here, okay, in geometry, I was taught that this is very important. And I'm about to show you something, and a lot of you are going to say, oh, this is what a tangent line is. This is only true geometrically for what we do with a circle. Okay? In geometry, somebody said a tangent line is a line that intersects the circle at a point and only intersects the circle at that point. Only intersects it at one point. Well, what would that be? Right about there is the tangent line to the circle at that point P. And you can see, yeah, it only intersects that circle at that one point. Okay? That definition that I just gave you only applies to what object? Only applies to a circle. So please don't take that as the definition of a tangent line. I still have not defined a tangent line, and I won't do so until chapter 3. Okay? But this sort of gives us a little bit of a picture of what's going on. And what I'd like to do now is I'd like to add some directional arrows to this circle. Let's say we were moving in a path along this circle, and I just put some arrows there to show the direction of that path. Okay? Well, let's now look at that point P, and on what we're claiming is the tangent line, let's go ahead and put more of those directional arrows. What do we notice about the directional arrows at the point P? Well, it's a clutter diagram. They agree with each other, right? You're traveling in the same direction as you pass through that point. Okay? That's a better understanding of what we mean by a tangent line at the point. Okay? Again, we're not going to get the definition of it tonight. We've got a lot of building to do, a lot of groundwork to cover. Okay? But this sort of gives us a rough exploratory definition of a tangent line. Okay? So what I'd like you to do is go ahead and draw, this is a little zoomed in, go ahead and draw a tangent line to this curve at each of these points. Point A, at point B, and at point C. So maybe for a tangent line at A, we get something like that. Yours might not look exactly like that, but it should be pretty close to that. Okay? Meaning that at that point A, the curve should match the direction of that. If you put those little directional arrows on, they should be in agreement at that point. Okay? Likewise, we can do the same thing here on B. And maybe something like, that's not quite right. Let's do it like that. See if we can do this. There we go. Something like that, maybe. Okay? And then let's do one at point C. Maybe something like that. Okay? Now, I want to highlight something real quick. Okay? First of all, does this curve have more than one tangent line? Yes, it has many tangent lines, infinitely many tangent lines, right? Okay? So whenever you talk about a tangent line, you can't just leave it at that. I can't say, what is the tangent line? Or where is the give me the slope of the tangent line. Okay? You should always specify a location. What is the slope of the tangent line at A? Draw the tangent line to the curve at B. You see what I'm doing there? Every time I'm giving you a location where you give the tangent line. Okay? Notice that the tangent line at C, does it just intersect the curve once? No, if you were to extend this line, which I didn't do, it would intersect the curve 2 other times. Okay? So this idea here, unfortunately, I have to sort of start with where you're at, and a circle is a good place to talk about a tangent line. But on a circle, it has the property that the tangent line only intersects the curve once. But that is unique to well, I shouldn't say unique, but that is particular to a circle. Okay? Not necessarily every other curve. And just to keep that in mind, this curve C intersected the line more than once. Okay? Okay. All right.